So, this is an interview and a great pleasure for me to making this interview with Dr. Karlheinz Steinmüller from Z-Punkt and the German node of the Millennium Project. Yeah. Welcome to this interview.
Yeah, it's also a pleasure for me.
And we are now at the Helsinki office of Finland Futures Research Center, University of Turku. So I would like to ask you some questions about the changing world, about all these uncertainties and surprises that are happening. So you have actually raised the awareness that we are living in a VUCA world. Yeah. Can you open up a little bit what this VUCA world means?
Well, VUCA simply means V for volatile, that means ever changing. U for uncertain, you have always problems to predict. C for complexity, that means many factors interacting. And A for ambiguity, that means that you have difficulties to make sense of it.
Yes, and actually all those concepts VUCA, they are important in future studies, and I would like to, especially this ambiguity is really interesting, because doesn't it mean that there are different interpretations when we are going to make sense of the change and world?
Yes. In a way, future studies lives from the VUCA world. If the world would not be volatile, uncertain, complex, and with ambiguity, we would have no job. So it's very helpful and supportive for us.
That's right. It's food for our field. You have been called Mr. Wildcard because you are an expert in this specific niche in future studies. What is your definition of a wildcard, and can you give us a recent example of a wildcard?
Well, wildcards are events or developments with a very low probability before that event and with a very high impact on the conduct of business or on the development of the world in general. And because they have a low probability and they have a high impact, they come for most people as a surprise. And if you have a surprise, you react not in an adequate way. You have no plans for it. And my main message is that we should regard wildcards so that we can think in advance and have preparations, have always a plan B or a plan C in our mind. Recent examples are simply, for instance, think about the Brexit, which happened even to most British foresight people as a surprise, not to speak of the European ones, or even the election of Donald Trump to American president. So such things happen always in politics, but there are also technological wildcards. So 20 years ago, nobody would have depicted a future in which smartphones play the role they now have. And so in a way, this was also not as an event a wildcard, but as a development a wildcard. And I myself are very open to wildcards, and I like wildcards because I experienced one really big wildcard, and this was the fall of the Berlin Wall, the implosion of the Soviet Empire, and German reunification. And it came even to German science fiction writers, to most of them at least, as a surprise.
Okay, so then what do you say if a wildcard gets identified beforehand? It's not a wildcard, really? Or
sometimes I distinguish black swans and wildcards. Black swans are the real unknown unknowns, the things for which we not even have a name, which are really not in our minds. But wildcards are things we have already identified, but they are different from risks, since we cannot really assess a probability. They are singular events without any precedent, so that you have problems in assessing also their impact. So we can only say, well, low probability, high impact, but we have to guess the probability, and we can speculate about the impact. And this, of course, is wonderful for a futurist.
Yes. And then how about if we look at the past? So can we, do you think that we can learn from past wildcards and black swans? And should we learn?
Yes,
how
we can and should. For instance, in 1996 and 7, there was a possible wildcard called Y2K, or Millennium Bug, the year 2000 computer problem. And because people identified this as a possible major disruption for the, not only for computers, but on everything which depended on computers, they took preventive measures, and they deployed new software, and therefore this wildcard did not happen. It was mitigated,
right.
and
Right.
this can happen to a poor wildcard. So we really can do something about it. Or think about the election of Marine Le Pen to the French president.
Yes.
It did not happen. It was a wildcard, but fortunately in France, the non-populist forces were strong enough to prevent it.
Yes.
So it's worthwhile to think about wildcards.
That's right. Then a little bit about the concept of weak signals, because weak signals or a cluster of weak signals can be behind a forthcoming wildcard or black swan. But according to your observations, can you name some examples of recent weak signals that have not yet been paid enough attention to, that we are ignoring some kind of weak signals?
Well, 1 or 2 years ago, I would have said that the sudden decline in life expectancy in certain group of especially male population in some countries would be a weak signal. For instance, in Russia we had it after the fall of the Soviet Union, or in parts of the United States, in the Rust Belt, we had it in the low-income white population. And this was a weak signal for political changes, since people with such a bad living situation become angry and try to vote for populists or to do something stupid. So this is a weak signal. The problem with weak signals is the signal alone doesn't mean anything.
Yes.
You need always an interpretation. You can go around in a city and observe what's changing, but if you have no interpretation to the changes, it's a weak signal, but for nothing, or you don't know for what, and so it is no help for you. Then the concept of weak signal in itself is a little bit difficult, since what does weak really mean? Weak with respect to what? Perhaps to the impacts of the real thing for which the weak signal is a signal, maybe, or weak in comparison to other signals.
Yes.
You have always noise levels. In the present, noises which, for instance, come from trends. The trends are very loud noises, if you take it, and the poor weak signals are not strong enough against these noises. And the next is a term signal. If you are a communication engineer, you would say no signal, since nobody has sent it. So it is one of the metaphorical terms
Yes, yes.
of foresight. Helpful, but one should handle it with some care.
Yes, and critically. And it's polemic, and it's also subjective. Weak
Yes.
to whom?
Yes.
Yeah. Then let's turn to the technology foresight, because it's one of your key interests and also mine. So how do you see the role of technology foresight within the field of future studies at this moment?
Well, I think traditionally technology foresight was overemphasized in future studies. since one could rather easily design roadmaps for the future development for nearly established technologies, not so for really emerging ones which are not yet here, but for the ones we have already the first prototypes or which are just leaving the labs. So one could do something with it in difference to social foresight, which is much more difficult since it depends to a very high degree on perceptions and on even on ideologies, on blindness, on your own position and on such things. So foresight people usually took technology as a starting base. And I hope, and I think really, that it is now changing a little bit. And when we put more attention to black swans and to wildcards from the social sphere, we avoid being too much focused on technology.
Yes.
Nevertheless, technology foresight stays an important part of foresight.
Yes. For me as well, I think technology rather as an enabler. It shouldn't be like the main driver or the dominating factor within future studies, but an enable and a platform. But on the other hand, we are in a very interesting position now with these artificial intelligence developments, etc. So what is, according to your view, what is the biggest challenge when we are developing interfaces between humans and machine?
Well, we have already interfaces between humans and machines, and these are all these apps we run on our smartphones.
Yes.
And it is for me difficult to predict what could happen in the interaction between the human mind and artificial intelligence. I do not so much think that we need brain implants or such things, but that in everyday life we rely more and more on all these smart gadgets and software tools which give advice to us, which perhaps navigate us in certain directions, which help us sometimes, which prevent some stupidities of us perhaps, or which introduce other kinds of stupidity in our behavior. So the interaction is the interesting thing. And what we have observed in the last years is a formation of these so-called filter bubbles. And these filter bubbles are the outcome of such an interaction between people and the internet and all the low degree of intelligence which is already in the internet. I mean search engines and so on. Yeah. And therefore I expect much more in that direction. And the worst which could happen is that everybody is living in his or her own personal bubble, surrounded by his own artificial intelligence butlers or helpers, and detached from other people.
Yes.
And the best which could happen is, of course, that these tools help us to communicate better with each other, to understand better what the others want and what our own deep wishes are.
Yes, and improve the state of humankind and nature, etc.
But as always, it will happen otherwise, and the future lies between all the scenarios we develop.
That's right. And now let's talk about a little bit of the renewable energy and renewable energy revolution, which is actually the topic of our Tekes-funded Neocarbon Energy project. And when thinking about this renewable energy transition and revolution, what would you say as the key driver and as the key obstacle?
I suppose there is not one driver and not one main obstacle, but there are different drivers. One is of course market penetration, and that more people use renewable energy. So it is driven partly by lifestyles and partly by, say, societal consciousness. And the other is technological development combined with market developments. So I would say in the last years, one of the key drivers was China with its strategy to produce photovoltaics at extremely low prices. And this helped the field and pushed a lot of German companies totally into non-existence. So there are such drivers. And of course, there are not only obstacles but enemies to this revolution. Large oil companies, for instance, who should find new business models, perhaps without oil, or using oil for more sensible things than only burning it. And obstacles, of course, is a certain inertia of society, that it is for people, not so easy to change their own life, to rely more on renewable energy, and to, for instance, in the transportation sector. The transportation sector anyway is the one with the biggest obstacles to the energy transition, since it relies to a large amount on fossil energy, and only rail transportation is running on electricity now, and even that is partly fossil electricity. So it would be a good thing if we had not only electrical cars, but electrical cars running on renewable electricity, and not on the grid portfolio of different energy sources.
That's right, it should be.
So much change is necessary there, and I think we need other revolutions combined to the energy transition, and one is the transportation transition and the food and nutrition transition. So and these fields are much more difficult to change than, say, heating of buildings.
Yes, it's just mainly technical thing, but social aspects are related to lifestyles, etc.
And then there is another interesting problem, perhaps sometimes even an obstacle, that the power demand of all our smart gadgets, of the internet and all the devices is increasing at terrible rates. And in some places it's already 10% of total power demand. And some companies installed their server farms already in northern countries behind the polar circle, so that they are cooled by nature.
And the number of gadgets is increasing all the time. And you have to have extra batteries with you to charge. But then, can you imagine a black swan that would actually propel this renewable energy?
Yes. There is one very technical, that is superconductivity at room temperature. Well, I'm a physicist, and therefore I like such things. Up to now we have superconducting materials at the temperature of liquid nitrogen. That's somewhat about minus 170 centigrade. That's already rather hot in comparison to absolute zero. And if we would succeed in developing a material which has no electrical resistance at, say, 0 degrees centigrade or perhaps 25 degrees centigrade, we could construct storage elements, superconducting circular currents with a really high capacity and no loss. And we could build such super batteries into cars. And we could use superconducting wires for high voltage transmission along the land sides without any losses. And especially the solution to the storage problem would help wind power and solar power quite a lot. This is one of the main bottlenecks now. And superconductivity at room temperature would be a solution, but it is highly highly improbable.
Yes, yes. And it fits the definition of a black swan. How about geopolitics? Can you imagine a black swan for Europe? And that would have a dramatic impact on Europe. What kind of black swan?
Yeah, one can imagine a lot about a better political architecture of Europe. For instance, if nation states, the member states, which are still the strong parts of the European Union, would give a little bit of their power to first the cities, the communities, the regions, so that we would have not only a European Parliament with the parties from the different countries, but a real secondary parliamentary body with representatives from the regions and from the main cities. And they would have another say in it than the parties and the nation states. It would bring Europe closer together.
Yeah.
And another idea would be to give some NGOs more influence, but NGOs are lobby groups itself, so it's difficult to look which would be the right constitution of this advisory body for the European Union.
Yeah, but it would create some kind of landscape of new empowerment.
Yes,
kind of
it would need a new political architecture for the European Union, not United States of Europe, but something like United Regions of Europe and the United Tribes of Europe.
Yes. And now, the final question, because yesterday you gave an excellent talk at our 5th Near Carbon Futures Clinic, and the title for that clinic was Surprising Energy Futures for Testing Resilience of Renewable Energy World with Black Swans. And we had some 50 participants and etc. And we tried to anticipate black swans and discontinuities and their implications on our society. Considering your experience yesterday at the clinic, was there something that struck you or you found surprising personally about this? Because you heard also the results briefly presented from the groups.
Well, I was struck by the very strong part played by political considerations. Of course, there were lots of black swans related to technology, but there were also very strong thinking about political architecture and what would be needed from political leaders. And perhaps the most important black swans for renewable energy are there. They are not technology, not superconductors, but they are super foresight in human brains.
Okay, yeah, that was a nice observation. So, Dr. Karlheinz Steinmüller, thank you very much for this interview.
It was a pleasure from me, Sirkka.
Thank you.
Okay. Yeah.
So.